Okay, fantastic. Let's get started then. Welcome to everyone that's on board today and for those who are joining us online. Today we have a quick webinar to go over the red-legged earth mite decision aid tools that we've been developing and some recent advances. And James Maino is here to run through all these with you today. Feel free to use the chat to introduce yourself and to use for questions throughout the webinar. We'll be having a couple of times throughout the webinar where we can stop for having questions, and we'll also have the opportunity to have a chat at the end. So take it away, James.
Thanks, Lizzie, and thanks to everyone for coming along today. Yeah, so as Lizzie said, the topic is to just, go over some of the recent advances we've been making in red-legged earth mite decision aid tools. But I guess just to kick us off, I thought I'd get us all to a bit more comfortable with the chat function with a little quiz. If you could just punch in which number of these pictures here is red-legged earth mite into the chat. I'll give you a minute to do that, and we'll come back and review the answers. All right, I can't actually see the chat at the moment, so Lizzie, let me know when we should move on.
I can see it. We've got one guess of a 3.
All right.
No more guesses coming through.
No more guesses.
Oh, another 3. Yeah.
Perhaps it's because none of them, in fact, are red-legged earth mite. There might have been a bit of a pause there amongst the viewers. Sorry, that was a little bit mean, but look, red-legged earth mite, it's one of the most destructive establishment pest crops of grains. You know, and I guess historically we've been pretty reliant on these broad spectrum pesticides, which has not been great for off-target effects, you know, such as the emergence and spread of resistance that we've been seeing in synthetic pyrethroids and organophosphates. But really, at the end of the day, there are limited control options for this pest. And that's increasingly, I guess, evident as we keep seeing this resistance issues spread and increase across Australia. So there really is a pretty pressing need to reassess the management options for this important pest of grain systems. And that's exactly what this GRDC investment titled the Future Options for Control of Red-Legged Earth Mite in Australian Grains Grain Crops is about. CESA Australia is leading this project with contributions from the University of Melbourne and DPIRD in WA. But we've also got James Ridsell-Smith from CSIRO involved, who was the lead investigator of the AWI research investment that delivered TIMERITE. And we've been fortunate enough to secure some co-contributions from AgriFutures and MLA to extend some of the outputs into pasture production and pasture seed production growing contexts. So it's a 4-year investment with a number of outputs. One of the first of these surrounding insecticide resistance management, which is one of the priorities for grain growers. That's going to include surveillance and testing, which I'll talk briefly about later. We're also going to be exploring novel biological, cultural and chemical control options to, I guess, increase the toolkit that we have available for managing this pest. We're looking to develop additional IPM and grower tools through some pretty exciting field trials and IPM demonstration sites. And as you'll see today, as the focus of this talk, actual, I guess, interactive tools and calculators that can be used by growers and advisors. And all of this, like today, will be extended and communicated through a fairly comprehensive comms and extension program. But just to pause briefly here, I thought it'd be worth flagging to the viewers that we are, like in other red-legged earth mite GRDC investments, that there is a resistance testing service that is available for growers at no cost. And so I guess I just wanted to quickly flag, if you're experiencing any control failures or suspect resistance, or for any other reason want to get a population tested, to please get in touch and jot down these details here, or just send an email to Caesar Australia more generally, and we'll put you in touch with the right person. But Dr. Aston Arthur is leading that part of the project. But today we're here to talk about red-legged earth mite tools that we've been developing that will hopefully aid decision support and management around this pest. And principally that concerns the development of a hatch timing tool to estimate when these guys hatch in the field, seasonal risk estimator to get some, I guess, prediction of what your estimated risk is for the upcoming season based on a range of different factors. And future opportunities for developing and extending TIMERITE, which has been a very useful tool to growers historically since its development. Now, it's just important to flag that these tools are being developed for growers and agronomists, so that we're really trying to emphasize ease of use and practicality across these tools. And the tools that I'll be presenting today are really in the early stages. They're hopefully already useful, which is why we're having this webinar. But really, we've got a good opportunity across the duration of this project to further develop them and finesse them so that they're really addressing the needs and concerns of growers and advisors. So we're really keen for early stage feedback. So please don't hesitate to tell us which bits you like and which bits you don't. So we'll start with the hatch timing tool, and I guess a little bit of background. Really, hopefully we're all familiar with the red-legged earth mite life cycle. They're active during that sort of winter period and into spring, and they do this funny thing where over the summer they kind of go into a hibernation phase called diapause, and they go into diapause through these special kind of eggs that they make in the lead up to summer that are different from the eggs that they produce in winter. And then these diapause eggs hatch in autumn, as you're probably starting to see now in some of the regions. And really what this tool is about is incorporating the sort of past work that has been done on red-legged earth mite and the sort of temperature and moisture cues that cause hatching. So really focusing in on this part of the life cycle from that March, April, and even May period for red-legged earth mite. So that's when they hatch, and it's important to understand when they hatch because this really can inform our monitoring to ensure that it is targeted so that we can get out there when they're likely to be active and ensure that they are not damaging crops. And given that most of the risk surrounding red-legged earth mite is around that establishment phase, getting better clarity on when they're likely to be active can really save us a lot of time and effort when monitoring for this pest early season. So we're going to just switch over now to an interactive, I guess, demonstration of the tool. So here's sort of what you look like. I think Lizzie will make this web page available for the viewers who want to follow along or use this tool for this coming season. So she'll probably put that in the chat, hopefully. But here's what it looks like when you go to that website. The instructions are basically hopefully easy enough to follow. You can zoom into your region of interest. So let's say we're over here in Western Victoria. You click the particular point in space, and if all goes according to plan, we see what it's done is it's extracted climatic data for that particular location. And so here you can see a plot of the climate for the year to date. And if you remember back to that life cycle plot, you know, it's temperature and rainfall which really determine when this pest hatches in the early season. So we need to get sufficient rainfall, but also low enough temperatures for this pest to hatch, and that's what is being predicted here. So here you can see for this particular location in Australia that egg hatch was predicted on the 21st of April. However, if we went a bit further inland, you can see that it's a very different result. We just haven't reached the rainfall and temperature conditions required for hatching for that point in time to date. But if we scroll a bit further down, you can get a sense for what the predicted hatching date is across the last 25 years. So you can kind of see here that across the last 25 years, the probability of hatching in any given year would be about 10% by 5th of May, 20% by 9th of May, and today's date, 11th of May, we've got a 30% chance of hatching. And so you can kind of see that it's in the lower end probability of what is estimated based on climatic conditions for the last 25 years. So not too surprising that for the current year's data, they haven't been predicted to hatch. So I might just pause there quickly just to see if anybody has any questions at this stage, if that was easy enough to follow.
Feel free to write your questions into the chat or unmute yourself and have a chat. Was everybody able to open the link okay and to access the tool online for those of you who are trying? James, I know you can't see the chat, but we've had a couple of people say that they have been able to access it. Di says hers have been predicted for next week, so that's interesting. Yep.
So that's a great point. I guess you know, as part of developing this tool, we're really keen on getting some in-field validation. So if you get a prediction for your particular region and you go out and you notice that they've been there for the last couple of weeks based on their size, if they're all adults, or they're not there when they are predicted to be there. I mean, that's great information that we can utilize to, I guess, fine tune this tool to make it, I guess, better in the future. So throughout the current investment, we will be collecting additional field data, but I guess anything that users can pass on to us is just going to be further information that can be incorporated. All right, so if there's nothing else, Lizzie.
Sorry, James, we do have one question from Di. She's asking, where's the best place to check in canola, lupins or lucerne?
So it's probably more to do with where the numbers have been high in the previous year, which we'll come to in the next tool. But then following that, it's also, I guess, where the conditions have been cooler and wetter. So if in a particular crop you've got bigger canopy, I mean, you're not going to have canopy cover early in the season, but you know, if there are weeds that are providing that sort of cooler and wetter microclimate, those are going to be the places where you first start seeing activity and hatches. So for those who might irrigate, that can also bring a earlier onset of hatching in this mite. And I guess that raises, yep.
I was just, there's a question as whether they're found in the stubble as well.
So they can be found, I guess, in the stubble because the eggs will just hatch wherever they happen to be laid. And in the early stages of development, they can feed even on sort of microflora, so things like algae that occur on the soil surface and things like that. So even if they're not feeding directly on the stubble because, you know, they don't eat, they're not detritivores, they don't eat dead plant material, they may be eating some of the microflora like algae that is found nearby to the stubble. But in particular, you know, your sort of broadleaf weeds are going to be really important for these guys.
James, just before you move on, there's just some information here from somebody in the chat. They've said that their hatch date was predicted for the 19th of April, and they've already found a couple of small ones 10 days ago.
Yep. So that, to me, would suggest that that's pretty close. if they're small, you know, the life cycle takes about probably in autumn, you know, 4 to 5 weeks. So that potentially is bang on the prediction there. So I'll write that down. If you can provide any information on the size of the mites, that might be helpful too. Thanks for that. All right, if there's nothing else, I'll move on, Lizzie. Okay.
Yep, you're good.
Great. So next steps, I've already sort of mentioned some of these. I'm keen to validate these estimates just to make sure that it is doing the job that it was intended to do. So not only reports from end users, but also additional collections made under the current project. But really, we're also keen to get used back on the actual interface. You know, is it buggy? Is it easy to use? Does it make sense? Is it logical? So don't be frustrated if you're finding it hard to use. Channel that frustration into useful feedback for us, and we'll try and improve the tool. And as I mentioned earlier, we've got some co-investment from MLA to try and extend this tool into pasture production context. So we're going to be validating it under a range of different growing contexts besides cropping. And I guess just before I move on, if you have thoughts on the tool going into the season, just please drop me or anyone at CSER a line. Would love to hear from you. So second tool, seasonal risk tool. So this really has come off the back of a previous investment. This was a project led by BCG, which as part of one of the components, we led to a best management practice guide for red-legged earth mite, which included a range of information that on ID, life cycle, paddock risk, but most importantly, the kind of seasonal considerations that might be affecting your risk factor for your particular year. And so to get at this, a method was come up that basically determined your red-legged earth mite risk based on a number of different growing factors and conditions, and then I guess provided some management advice depending on your level of risk. So here's the sort of risk table, how it looked in the guide. And so for those of you who are familiar with this, probably don't need to go into too much depth, but just very briefly now, you can kind of see that each line corresponds to a particular choice, option 1, option 2, option 3, and you fill in those options all the way down the rows, and you come up with a risk score. And there was, I guess, a table for depending on whether your last year's paddock was in crop or in pasture. And then this risk score was then used to determine different interventions to reduce your risk at these different management time points throughout the season, from late spring, pre-sowing, seedling establishment, and during that winter to spring growing season. And then the actions were then, I guess, provided based on whether or not you were low risk, moderate risk, or high risk for red-legged earth mite pressure. So what this tool does, and you can similarly as before, you can find the link here. Hopefully Lizzie will be able to provide that in the chat as well. And if I jump to it now, all this tool does is provide I guess, so you don't have to get a pen and paper and add up the scores yourself. It kind of does that heavy lifting for you, not that it was a particularly difficult sum, but basically you go through, you answer all the questions, and it spits out your risk score for the particular year. And the potential actions and management options that you have through that correspond with your risk factor. So the kind of things that affect risk are the actual crop type. So you have some crops that are more favorable for red-legged earth mite that can cause the populations to build up. The weediness of last year's paddock can also have a pretty large influence on population levels. Crop density, again, as we were sort of talking about, how it modifies the microclimate, making it wetter and cooler, that can affect your population numbers. Also, just what you've been observing. So how do the numbers that you saw last year influence the numbers that you may see this year? What, I guess, management options were used in the previous year, and whether or not TIMERITE was used in the previous year, and the particular crop that you're growing in the current year. And so if you sort of, I guess, start playing around, I'm just going to go through and select a few of these at random, you can start to see that your risk score is changing. So now we're in moderate risk and climbing. And yeah, and then the table changes as well. So really at this stage, it's just meant to be, I guess, mirroring what is available in the guide, hopefully just making it a bit easier to use. But from here, we'd like to, I guess, go beyond what is already available in the guide and start incorporating, I guess, greater cost benefit information on your different management options and on the potential impacts that red-legged earth mite may have in your crop. So it's very simple to start. We just wanted to get something out there for initial feedback. Is this kind of thing useful or not, easy to use or not? And we'll use that sort of early stage feedback to guide the further functionality that will be built into it later. As I said, we understand that with growers and advisors that cost is a really key concern in terms of the economic impacts that are likely to occur from your red-legged earth mite risk, but also the costs of different management strategies, whether that's, you know, chemical options, cultural options, increased monitoring and so on. So hopefully building that into the tool, also making it a bit more quantitative rather than this sort of qualitative score, will really help to enhance the precision around estimating what your risk will be, but while keeping it all simple and easy to use, because that's really another priority at the end of the day. So perhaps I'll just pause there for any initial thoughts or feedback on the tool. If anyone wants to just chuck it into the chat or ask it directly.
Dave was asked if we can share a link to the risk table. Yep, I can dig that up for you.
So the risk table being the management guide, best practice management guide. All right. Well, I guess if there's nothing else, like the hatch timing tool, if anybody has any further thoughts on how to improve the usability, functionality, or usefulness of this system, please get in touch. At the end of the day, as I said earlier, this is a tool that we really want to be useful for growers and advisors. So the only way we can maximize that is by getting feedback. So I really appreciate anything.
We've got a suggestion here for number 6. It would be good to have a simple number. Not rather than possibly the text. That might be what that's referring to.
Right. Okay.
Answered. Oh, a simple no. Was insecticides used? So just having no being one of the answers. Sorry, got that, Di.
Yep. No, that's a good point. Thanks for that, Di.
And I've pasted in the link to the management practice guide.
Great. Okay. So yeah, I won't go through all the actual recommended actions here. Please either have a play with the online tool, or just go back to the original guide if you are interested in what's available. But as I said, this is really just the starting point for future work in this sort of space of estimating seasonal risk for red-legged earth mite and management options. And one thing I'm particularly excited about through this current investment is the scope to, I guess, obtain further information on the costs and benefits of different management strategies, as well as, I guess, testing some of these more novel management strategies in real life growing situations. So we've got a number of sites where we're running, I guess, field scale demonstration sites. So ranging from a couple of hectares to up to around 10 hectares of field sites where we're trialing novel management strategies. So really exciting stuff. And when there's, not only does this sort of give us an opportunity to collect additional data on some of the numbers behind these management considerations that will feed into the model and make it less qualitative and more quantitative. It'll also help us put some numbers on the costs and benefits of different alternative management strategies. So we've got, just very quickly here, we've got a site in sort of south of Echuca, mixed cropping, low input system with minimal herbicides, fungicides, pesticides, and synthetic fertilizers. So we'll be comparing that against the more, I guess, conventional or just standard for the region red-legged earth mite management. We've got a site West Victoria, 50 k's sort of west of Ballarat, and here we have a grower who's really focused on IPM and avoids, I guess, foliar pesticides wherever possible. Really keen on enhancing beneficial activity. So again, you know, what's the cost benefit of that kind of approach in his growing circumstance? And in site 3, which is another, this is I think, grazing primarily business, northeast of Bendigo, where the grower is currently facing resistance management issues to organophosphates. So here we're starting to get a glimpse of what happens when your chemical controls start to fail, and what other options do we have, both chemical and non-chemical. So we'll be trialing a bunch of different things at this site as well. So just wanted to flag that with the group, just so you know, I guess, what's sort of going on behind the scenes. But also, I guess, just like we're trying to get feedback on how useful these tools are, I think these demonstration sites and field trials really give us some scope to really pursue some interesting research questions, which will then be incorporated into these tools. So if there's a particular novel management strategy that you're particularly interested in collecting, putting some numbers behind, we'd love to hear about it. So get in touch, and we'll see what we can do. But yeah, so these field sites are going to be a sort of a core component of increasing our understanding of the cost benefits of managing your seasonal risk for red-legged earth mite. And at the end of the day, really what we want this tool to do is summarize all that complex ecological knowledge that has been accumulated through years of research on this pest, and relate that back to the relevant management advice. That's going to be, you know, very context dependent, but putting that all into a user-friendly interface. So yeah, so as I've been saying, any feedback on these things and the IPM trials that we're planning, it's going to be really valuable for ensuring, you know, that we deliver value to growers. So TIMERITE, future opportunities. Just like before, we were focusing on the hatch period. What TIMERITE does is it focuses on a different stage of the life stage, which is that part of the life stage in that spring period where red-legged earth mite are beginning to lay those special diapause eggs that get them through that hot, dry summer period. So better understanding when that occurs, which is the whole basis of TIMERITE, allows us to really time those spring foliar sprays where they're required. So this really came back off the back of a AWI investment which led to TIMERITE, although it has since been widely adopted by grain growers as well. But the premise, as you're probably all aware, is to just, you log into this site, you punch in your latitude and longitude, and it gives you back a date, whereby if you spray on that date, you're going to hit them before they've, I guess, dropped all their diapause eggs, and I guess reduce that population in early summer in the next season, early autumn in the next season. Pardon me. So here's the scientific paper that I guess gives the basis of TIMERITE, and you can really boil down the guts of TIMERITE down to this simple equation, and you don't have to really understand what the equation is doing, apart from noting that we have day length in the equation and long-term growing season. So really, when you punch in your longitude and latitude, that is all that is being used from that input. And long-term growing season is really just estimated as that period in time where your rainfall is above your temperature. In fact, double your temperature. So here 40 versus 20. The axis is different for rainfall and temperature. Anyway, the details aren't important, but I just wanted to sort of very quickly communicate what's happening in the guts of TIMERITE. It's just day length, long-term growing season, which really driving that prediction across all the areas in which it's applied. And this model has some certain strengths. It improves spray outcomes in many situations. It's been demonstrated in a variety of different scientific publications. It's simple, it's easy to use, it's been widely adopted by growers and producers. The date is fixed between years, which makes it easy to remember. But this also causes some weaknesses. So by assuming that the date is fixed across years, you're not allowing for variability in climate across years, particularly in Eastern Australia, where we have less of that Mediterranean climate that we see in WA, where this was developed. There've been some accuracy issues. We get that, I guess, high variability in spring rainfall and temperature, which can really cause that TIMERITE date to vary, or more specifically, the production of diapause eggs to vary. And this very simple model doesn't utilize more recent research findings on how temperature and moisture affects diapause egg production. So as you can see in that equation, we've considered day length and long-term growing season, which indirectly includes some measure on temperature and moisture. But even fixing those things, which is what was shown in this more recent study in 2019 by Shen Cheng, you can tweak in the laboratory when that diapause date is based on varying temperature and moisture. And as you'll see in hopefully future webinars, we've got a range of different interactive tools that really, I guess, incorporate that regional variation and climatic variability in hopefully what is an easy to use and an intuitive framework. So there's no reason why we can't do this for TIMERITE, incorporate more of that climatic variability and accuracy that can be afforded by the recent studies that have been conducted. And so that's what we're really planning under the current investment as well. And we're still a bit in the early stages of that, but I thought it'd be worth flagging that with the group today, just what the plan is and if there's any, I guess, feedback on how TIMERITE is currently used and any of the limitations that they're seeing. So as I mentioned, we're going to be incorporating other climatic variables to increase that precision, but also real-time climate data. So using data that is relevant for the current growing season and not just these long-term averages that are used in the previous TIMERITE model. And of course, we want to validate all of these new predictions through not only the historical data that exists, which will be compiled through the current project, but also through additional sampling that's going to be occurring through the current investment. So as I said, we're really keen to hear any issues or suggestions that you might have that have emerged from your use of TIMERITE, and what you'd like to see incorporated into sort of future iterations of the tool. And as I've been saying throughout, these tools are really being developed with growers and advisors in mind. So yeah, the more we hear from you guys about that, the better these tools will be and the better they'll address the needs. So I might just leave it there and take any questions that anybody has or feedback. Oh, and
Excellent.
yeah, I'll let Lizzie give this poll.
Yeah, thanks so much, James. That was really useful. I think it's a good overview for everybody that's online, and hopefully we can share the recording online as well. Do let your questions come through on the chat. And also, just to finish off, before you head off, we'd love to get your thoughts on the 4 poll questions are there. We're just asking you whether you'd be likely to incorporate these tools into your management, which tools are the most useful for you, any additional features that you'd like to see, please feel free to put that into the chat. And would you be interested in similar webinars like this into the future? So we're always happy to be very flexible on the types of webinars that we run. So if you've got any ideas at all, we're very happy to run them. And we will be doing an additional tools and management webinar over the next coming weeks.